Welcome, everyone. It's really gratifying to see such a large turnout for this colloquium on the topic, Two Mistakes in AI Design, ? And we're very fortunate to have as our main speaker, Ruth Chang, who is Professor of Jurisprudence here at the University of Oxford and a Fellow of University College. There's always been rival traditions of moral philosophy in Oxford, and one tradition very much emphasizes plurality of values, their proneness to conflict, the need for judgment in resolving those conflicts. And that's the tradition of people like Isaiah Berlin, Stuart Hampshire, Joseph Raz. And in that tradition, very distinguished tradition, is Ruth. And in fact, it's probably arguable that no one has done more than her to really investigate the question of the relationship between values. And today she'll be leveraging all that research to talk about its implications for artificial intelligence and the project of aligning artificial intelligence with correct values. We're also very fortunate to have two excellent commentators. The first is Dr. Alex Grzenkowski, who is a reader in philosophy at Birkbeck in the University of London, where he leads the London AI and Humanity Project. And secondly, we have Professor Philip Corrales, who is the inaugural McCord Professor of Philosophy and AI at the Institute for Ethics in AI. And he's also the founder of this new project, the Human-Centered AI Lab, which began just late last year. And he's also a fellow of St. Catherine's College. So we're going to have Ruth deliver her talk, then we'll have the commentators, we'll have some Q&A amongst the commentators, then we'll throw it open for general discussion. So I'm going to turn over now to Ruth, who also has slides.
My talk today is a philosophical look at AI design, and in particular, I want to moot a possible value-based model of AI design, what I call the parity model, that corrects what I believe are two fundamental mistakes about human values currently embedded in AI design. Now, by AI, I mean something incredibly broad, basically any machine technology that attempts to do what humans do when humans attempt or do things. So I want to talk about both machine learning and symbolic systems, and you'll see I'll be kind of switching between them. But the overall message is something that applies to both types of system. Okay, so we can start with an overview of 4 clusters of open problems in AI design. And the first set of problems concerns learning. Right now, AI can't generalize. It can't remember what it learned a minute ago. It can't translate what it's learning in one domain to another domain. It can't understand as opposed to just know things. Today's LLMs don't get sarcasm and other nuances of linguistic norms, and nor does it have any common sense. Next cluster of open problems, reasoning. AI doesn't reason very well. One problem has to do with how to get AI to infer causal as opposed to merely probabilistic relationships. So an AI can determine that there's this high correlation between increased consumption of ice cream and increased drowning, but it doesn't understand that there's no causal relationship. Recent chain of thought reasoning works especially well for mathematical queries, but not so well for even straightforward deductions. And it's pretty hopeless at normative reasoning. Philip has helpfully suggested a general arithmetic or problem-based approach for AI reasoning that allows certain fallacies to be avoided by human questioning. But I think we can all agree that AI still has a long way to go. Third cluster has to do with safety and control. And I think of 3 kind of strands of the safety and control cluster of issues. The first, made famous by Nick Bostrom, but with a long history, is they'll become our overlords. And the general argument is something like, we currently build machines that are smarter than us. They will build machines that are smarter than them, and pretty soon we'll be enslaved. And there's interesting questions here about the transitivity of intelligence and so on. But that's the first sexy strand of the safety control problem. The second strand concerns safety on the ground with existing AI systems. And Roel Daub in the Netherlands has an interesting project here that tries to see, he's trying to develop safety protocols that take what he calls a socio-technical perspective. So zoom out, don't just worry about the safety of the actual machine, but think about its implementation, et cetera, et cetera. And then the third open problem under safety and control is, you know, the bad guys, the abuse problem. Okay. Last but not least, there's the alignment problem, roughly the problem of getting machine processes and outputs to align with human values. I prefer to understand alignment like this as a gloss. Alignment is the problem of ensuring that A-out processes and outputs align with our human best considered judgments about what is, and now insert some evaluative concept, right, wrong, good, bad, nice, tawdry, etc. Okay, now of these 4 clusters of open problems in AI design, I want to suggest that alignment is the most important. This is because solving alignment is either a precondition or a means to successful resolution of the other 3 clusters of problems. So a machine doesn't count as learning or reasoning well if it learns to do things we judge to be bad or reasons to evil conclusions. Okay, moreover, one way to control AI is through alignment. By aligning AI outputs with our best considered judgments of value, we get a good dose of control and safety for free. So alignment is a means to control. So I think of alignment as the most foundational problem of AI design, and that's my focus here. So what is alignment exactly? Well, the locus classicus of the problem comes from Norbert Wiener in the 60s. Wiener described the alignment problem as follows: if we use to achieve our purposes a mechanical agency with whose operation we cannot interfere effectively, we had better be quite sure that the purpose put into the machine is the purpose we really desire. Wiener called this the problem of cross purposes. Now, current technologists, as far as I can tell, seem to follow Wiener's gloss of the problem. But Wiener's statement and the prevailing understanding of the alignment problem among today's technologists contains, I think, 3 problematic assumptions about the alignment problem. One assumption is, let's just match the machine purpose with human purpose. But as we know, philosophers in particular, some purposes should not be aimed at. We know the paradox of happiness. Our purpose is to be happy, but don't aim for happiness. So don't make a machine have as its goal your happiness. There's also the bound problem. So, you know, if I want to change a light bulb, I have to get a ladder, and probably you do too, but Robert Wadlow, the tallest human in history, who's 8 feet 11, just needs to raise his hand. Okay. Here's a second assumption built into the way I think people currently understand the alignment problem, and that is alignment is a matter of matching AI outcomes with what we want. And what Wiener said was what we really want. And in 2 weeks, Stuart Russell will be here in this Colloquium series trying to convince you that if we design AI to match human preferences, we can achieve provably beneficial AI. But I believe preferences are not the right metric for determining value alignment. After all, our preferences are one thing and our values are another. If we scrub our preferences with purely formal constraints, like we make sure you don't have any false beliefs, your logic is impeccable, and so on, you will improve your preferences, but you will still fall short of values. The only way to scrub your preferences cleanly enough so that satisfying preferences would achieve value alignment is to put as a constraint on your preferences values. So let me give you a diagnosis for why it is, I think, so many technologists assume that preferences are the thing, right, to aim for. Think of economists, right? Economists use preferences as a foundational element in their theories. And in economics, preferences play two roles. First, as predictors of behavior and as proxies for what is valuable for an agent, what will conduce to her well-being. So taking preferences as proxies for what will in fact be valuable to an agent makes sense when your aim is to aggregate, right, on the basis of observables, the well-being of a group of people in order to guide decision-making at, say, the policy level. Of course, if we were gods on Mount Olympus, forget the preferences, we would look immediately to facts about what would conduce to people's well-being and devise our policies accordingly. But we can't figure out what would, say, be Pareto superior with respect to every citizen's well-being, because that's just something we can't know in a pluralistic, complex world. But with AI, I believe, we have some hope, to be explored in a moment, of doing better than the economists by going directly to values. So we shouldn't assume what works for economics works for AI. Now, a side point about principles. Right now, the hot thing in ethics and AI is principles. We just need to establish some principles, and then that will provide guardrails in the development of AI. And that's perfectly great for governments and large institutions. But if what you're after is alignment, principles won't do. And here's a quick example of why that is. Take the principle, keep your promises. Right, to implement that principle, to know whether that principle applies in the case where you promise your friend you would take her to the dentist at the cost of your child being left home alone who's ill, right? We would say, oh no, that principle doesn't apply. So any application of a principle, which is by necessity something very general, requires investigation of values. So we can't get away from values. Values have the right kind of content and structure to get us where we want to go, namely alignment. Okay. Then the third problematic assumption, I think, is that there's just one alignment problem, right? Get machine outcomes. They don't really talk about processes, but we should include processes. Get machine outcomes to align with human values. But there are really two alignment problems. And by distinguishing these two separate alignment problems, we can, I think, uncover two distinct fundamental mistaken assumptions embedded in current AI. Okay, but first we should take a look at existing approaches to alignment. There are two main approaches. First, there's, of course, regulation. And if you look around the world, most regulation kind of follows the EU AI Act, right? They focus on risk. But it seems to me there are three problems with regulation. These are kind of familiar. One is, of course, it's very hard to anticipate the risks of AI. Like, who would have imagined that Facebook would be used as a platform for insurrection? Second, there's, of course, the huge lag time. The EU AIA was about 5 years from inception to implementation. And most importantly, because of the lag time, right, the regulation takes place in a shifting background of social structures, circumstances, practices, and institutions, some of which are actually created by the regulation that happened the year before. So, because the background is constantly shifting, regulations, it just can't keep up. So the way I think about regulation is, it's just a game of whack-a-mole, and essentially it has to be that. Especially if we think that there's a fundamental problem in AI design. Okay. Second strand of approaches to alignment are a bunch of different design interventions. Super interesting, creative. I really admire the technologists for coming up with these things. Here's a bunch of them. I only have 30 minutes, so I'm not really going to talk about them. But if you're interested, Andrew Ng has some cool stuff about data scrubbing, the prompt engineering. Do people know what that is? Like when you put in a ChatGPT, it's the hidden prompt at the beginning that says, don't say anything violent. Okay. And the most promising, according to technologists, view of how to try to achieve alignment or make AI better is reinforcement learning from human feedback. And that's, okay, I'm not going to tell you what it is because you probably already know. But the thing I like, the one I like the best, is Stuart Russell's inverse cooperative learning, reinforcement learning. And the reason I like it is because what Dylan Hadfield and Stuart and team are recognizing is that it's a mistake to think that you can just put in the purpose you want into the machine and then fix it up afterward through reinforcement learning from human feedback and get what you want. What they recognize is that you have to put uncertainty into the reward function. And then where, in my view, they go wrong is to think that the way the machine can learn what your purpose is by observing your behavior. So it's sort of straight down economics revealed choice theory. Okay, all right. But I think it's fair to say none of this really works so well right now. So we're not really in a position of getting alignment through design interventions. All right, so where do we stand? I think we're at a fork in the road. On one tine, I guess you'd say, there are those who think, look, there's no amount of reinforcement learning from human feedback and other clever remedies that can achieve alignment, right? We can think of them as the pessimists, and then the other tine are the people who say, no, look, let's just get more data and more compute. And then we'll see that reinforcement learning from human feedback will get us algorithms that pretty much align with human outputs. So in a way, there's a kind of stalemate. And what's going on is the people who are the optimists have all the money, so they're throwing all the money at trying to see whether this path will work. Now, can philosophers help? So one way to think about what I'm saying today is it's a philosophical argument, an argument from axiology, that is the study of human values, that more data and compute won't solve the alignment problem, right? We need to do something else. So here's a hypothesis. Progress in addressing alignment has been stymied because technology is designed on the basis of two fundamental mistakes about human values, mistakes which I believe must be addressed before there is to be any hope of alignment. Regulation and design interventions will fail to achieve alignment because they're ad hoc guardrails, limited in their ability to prevent misaligned AI from being created in the first place. So instead of approaching alignment by imposing ad hoc guardrails after it's been designed, we need a more radical approach, a re-examination of the fundamentals of AI design. In particular, we need to start devising frameworks for AI design that avoid the two mistakes about human values made by current AI design, or so I say. Okay, so what are these two mistakes about values that supposedly preclude alignment? To uncover them, I think we need to distinguish two different alignment problems. We'll see that one mistake can be found in each distinct alignment problem. The first is what I call the covering problem. How do we get AI to cover all and only the purposes we design it for? Stuart Russell put it pithily, in AI design, you get what you ask for, not necessarily what you want. So remember Amazon's hiring algorithm, the purpose in building the machine was for it to determine the best hire among tens of thousands of applicants for positions throughout the firm. So the purpose, find the best hire, was intended to cover all and only those criteria, like being reliable, productive, loyal, and so on, that are relevant to being the best hire. But what they built was a machine that not only fell short of covering the criteria for being the best hire, but also covered irrelevant criteria, like being white and male. So as it turns out, it's very difficult to put into the machine purposes that cover all and only the purposes for which you design it. This is the covering problem. Following Weiner, Russell calls this the King Midas problem. Right? You have one purpose, but you put into the machine a different one. Now, technologists think that you can solve the covering problem either by just being extra thoughtful about what criteria capture your purpose, or if they do machine learning and have a bunch of data, just do more reinforcement learning from human feedback. But I want to argue that these strategies won't work, and it's an axiological argument. Okay, but first we have to distinguish two kinds of purpose in AI design. Sometimes you want AI to achieve, at least in part, evaluative or normative goals, like finding the best candidate for the job, a morally good way to avoid war, a child foster care assignment in the best interest of the child, a fair prison sentence, and so on. Other times, the purpose for which a machine is designed can be purely non-normative or non-evaluative, like determining which of two business plans will yield the highest profit, which bail decision will lower the probability of recidivism, or which suite of medicines will save the largest number of lives. Right? They're supposed to have normative upshots, but they are not themselves normative goals. Now, you might notice that there really aren't many AI or, anything done by engineers these days that is of type 2. And why is that? Well, because even if your goal is to do something that's primarily non-evaluative, you want it to do it in a safe and fair and unbiased way. So the alignment problem is a problem for normative AI, and normative AI is pretty much all the AI we care about. So here's a question. Why think that a design that is appropriate for non-normative AI, which I think is kind of how a lot of technologists have been conceptualizing what they're doing, why think that's also appropriate as a design for normative AI? In particular, normative AI design makes the following critical assumption, what I call values proxy. You can always achieve an evaluative end V, such as getting the best hire, by pursuing instead a non-evaluative proxy P, such as close match with the CVs of people already on the books. And then you can scale this up across all sorts of different circumstances. Indeed, current algorithms for machine learning are systematically designed to achieve evaluative ends through non-evaluative proxies. But values proxy is false. King Midas shows us why. What are the king's aims? Well, he wants to have certain values in his life, to have the value of a loving relationship with his daughter, good health, happiness, knowledge and understanding of the world, rewarding friendships, making great strides, worthwhile achievements, maybe even peace in his kingdom. His mistake, like that of current AI design, is to assume that all of these values can be achieved by getting something non-evaluative instead, gold. So the first mistake of AI design is to assume, along with King Midas, that we can use non-evaluative proxies for our evaluative goals and purposes. Such proxies will necessarily fail to cover the evaluative aims and purposes for which we design AI in the first place. In this way, current AI design guarantees value misalignment. We need to design AI that avoids using non-evaluative proxies, at least in the main, to achieve evaluative goals. One way to do this is to adopt a values-based approach to AI design. This means a very radical shift in how we think about AI. If we're to achieve our evaluative ends, we should build AI to process evaluative, not non-evaluative data. So I'm going to return to this idea at the end. But first, let's hit the second alignment problem. This is the trade-off problem. Now, notice that the purposes for which we typically design our machines are multiple. You want the best hire, and that involves not some homogeneous monolithic quality like height, but multiple evaluative properties like productivity, reliability, loyalty, team spiritedness, and so on. And we have to figure out how to trade those off against one another. Okay. So how do standard technologists try to deal with the trade-off problem? Well, it's one of two ways. As we saw in Amazon, the machine learning people tend to fold the covering problem into the trade-off problem. Let's just find some non-evaluative criterion, like similar in CV to the people we've already hired and are doing well, to run proxy not only for the purpose of getting the best hire, but to run proxy for the trade-offs between the various components or criteria that make someone the best hire. The other strategy, more commonly used in rules-based or symbolic systems, recognizes that, look, there are multiple criteria that determine output. It assigns weights to those criteria and then evaluates a sampling of the output. And if the sample looks bad, it adjusts the weights until you get a good result, and then it hopes that it generalizes. Sometimes a principle is invoked to constrain the range of rates assigned to the criteria. What principle? Which weights? Who decides? Often it's up to the engineer. Now, there's a general philosophical problem with such symbolic systems that we can discuss in Q&A if you want, but we don't have to go into the weeds because there's a deep underlying problem with all current approaches to the trade-off problem, whether symbolic or machine learning, that allows us to see why approaches to the trade-off problem won't achieve alignment. The problem is this: current approaches to the trade-off problem make a false assumption about the structure of value. It's widely assumed that there are only three basic ways any two things can relate with respect to a value. One's got to be better than it, worse, or they have to be equally good. And if those three relations don't hold, the items cannot be compared. And if there are options for choice, you can no longer rationally choose. So we can model all choices and all evaluations by a balance scale. Should you give up an hour of your time for $100? Well, here's how you would proceed. You put the hour of your time on one side of the scale, $100 on the other, and there are these three possibilities. Your time is more important, less important, or equally as important as the $100, and that's it. But trichotomy is, I believe, a mistake. Hard choices demonstrate this. Should you be a computer scientist or an architect, have a child or remain child-free, give to malaria relief or your local soup kitchen? Well, sometimes we face choices between options, neither of which is better than the other, and yet it's a mistake to think it's appropriate to flip a coin between them because they're not equally good either. The choice is hard. And how do you know they're not equally good? Well, take the two things, make a small improvement to one of them. If that settles the matter, right, you suddenly learn, oh, look, if I gave my money to the malaria charity, I was wrong. There's an extra malaria net that will save an extra life. Does that settle the matter? No. Okay, so in hard choices, I want to say your options are on a par. They are comparable. One isn't better than the other, and nor are they equally good. Options are on a par when they're qualitatively different. You can compare them. Perhaps one is better in some ways, the other one is better in other ways, and they're in the same neighborhood of whatever matters in the choice between them. Now, parity is the fourth basic way in which options can relate, and it should not be confused with uncertainty, indeterminacy, incompleteness, or, God forbid, incommensurability. Okay, so the idea here is the structure of value is tetrachotomous, not trichotomous in nature. Now, current technological design makes no room for hard choices. At present, if you ask a machine whether you should choose A or B, it's limited to only 3 possible good, that is not to be discarded, outputs. Choose A, choose B, or flip a coin, where flip a coin is the placeholder for being equal good, incompleteness, uncertainty, etc., etc. Okay. On the parity design idea, there are 4 good outputs. Right? There's this 4th good output, which is, this is hard. Okay. So the second mistake about values made by current AI design is one about the very structure of values. AI design assumes that value is trichotomous in structure, which leaves no room for hard choices, in which options are on a par. But we humans face hard choices all the time. Machines, if they are to align with our values, should face them too. Now, it's important to distinguish parity from indeterminacy, incomparability, incompleteness, and so on, because what it's rational to do in the face of parity is different from what it's rational to do in the face of these other phenomena. Now, in a hard choice, here's something you can do. You can commit. That is, put your very self, or an entity you have authority to represent, behind a feature of an option, typically thereby making that option more valuable than it was before. And there's a whole metaphysical argument for this, but anyway. So just intuitively, by committing to, say, Harry, you make him the best person with whom to spend your life. Of course, you don't have to commit. Sometimes you're not in a position to be able to commit. So here's something else you can do in a hard choice. You can drift into one of the options. Indeed, you can drift into a relationship with Harry. You intentionally choose to be with him, but because you don't stand behind making your life with him, you don't add value to doing so. Many people drift into love relationships without commitment. This means that when Tom or Dick come along, Harry is not better, but on a par with them. So the way you understand values going forward when you drift is different from how you understand them when you commit. Okay, so far I've said that AI design makes these 2 fundamental mistakes about value, but I haven't said how AI design can be fixed to address these mistakes. So I want to end in the few minutes I have by suggesting in outline form a way in which AI could be designed so that it avoids these 2 mistakes about value. This is the parity model of AI design. And here are its 3 features. First, it takes a value-based approach, right? Instead of processing non-evaluative data, like where the candidate went to school, as proxies for an evaluative end, like being the best hire, it processes evaluative data in the form of evaluative judgments, like whether the candidate is loyal, productive, team-spirited, etc. So does the candidate make or have a history of making evaluative judgments that demonstrate loyalty, and then uses that evaluative data about candidates to make determinations? So it's sort of, instead of a personality test, it's a kind of values test. Okay, second, it makes room for hard cases. And finally, it's expressed by a new mathematical model. Okay. I feel like I have to say this. Okay, so in machine learning now, trichotomy is deeply embedded in Boltzmann rationality, right? So Boltzmann rationality, you get weights assigned to the different nodes of the neural net, And guess what? There are only 3 possibilities. This assignment of weights is closer, further, or equally as far from the reward as some other assignment. If your reward is evaluative, that's a mistake. There should be this 4th possibility. So you could have multiple legitimate weightings assigned to the nodes. Okay, if they're on par. Okay, so quickly, AI design, as it's traditionally understood, has these features. I think I've tried to argue or suggest that these are problematic. Instead, we can have the parity. The parity design, right? Okay. Now, let me just end with some implications of the parity model. If we take the parity model seriously, then the first question you should ask yourself whenever you're thinking about building an AI is my AI normative or non-normative? That is, do I want this AI to achieve some evaluative normative ends? And the answer to this question will affect whether something like the parity model should be at least on the table. Second, normative AI has got to be small. So if we want to achieve alignment, if we can't pursue evaluative ends by pursuing non-evaluative proxies across a wide range of circumstances, alignment requires us to develop small AI. Right? So scaling up, no matter how much data or compute you throw at a model, will be misaligned. How do we create small AI? Really hard. I mean, suppose we want to create hiring algorithms. Right now, we think, okay, let's just get a bunch of data, throw it in all right into a machine, and it'll figure out a general hiring algorithm to determine across different domains who the best hire is. On small AI, slightly self-serving, but you need philosophers. Philosophers will have to tell you where the normative joints are in the world, or put a different way, which problems can be solved by the same covering values. Right? So philosophers will tell you that the criteria that cover getting the best hire in a widget factory is different from the covering criteria for hiring in a hospital or in a university. And once you have those joints, then you create small AI relative to those covering criteria, and you will have hope, at least, of alignment. Okay. Right. So also, what counts as noise needs to be rethought. So, Kahneman, Sunstein, and Sibony usefully define noise as unwanted variation in algorithmic outputs. That is variation in the outputs where you don't want it to be. And the analogy they use is you got the target with a bullseye, and sometimes there's noise that makes you miss the target. And what they include as noise is, on the parity model, sometimes cases of hard choices. So sometimes when you miss the bullseye, what's really going on is you're hitting some other legitimate target. Right? So there are multiple bullseye, not one. Okay, a couple of applications. Okay, but not stochastic variation. Don't think of that. Okay, some applications. So, safety protocols. There's a big electrical company that is in the Netherlands. It's famous for being super reliable. You just always get your electricity. There are no brownouts, etc. But there are 10,000 people on the waiting list trying to get this. And AI technologists have been called in to create safety protocols that involve trying to balance reliability against access. If they had in mind a parity model, they could be clear about what it is that they're doing. right? Right now, they're sort of throwing their hands up and they're like, we don't know what to do, right? What counts as safe? And okay. Another application, think of autonomous weapons. One, according to someone who works on this stuff, major sticking point in a ban on autonomous weapons is that certain countries debate about the hard cases, right? Like, so if we have autonomous weapons, should the autonomous weapon be able to target a uniformed combatant when he's in his living room watching television? And if we had a parity model of thinking about when an autonomous weapon would engage, right, where the country could decide how to handle these hard cases, we could maybe get closer, not to an outright ban, but something close to restricting the use of such weapons, right? It's these hard cases that are causing all the problems in the treaties being developed. Okay. Finally, there's healthcare. So someone I know has done a study of the last, there are 11 published healthcare algorithms from 2023 to 2024. And I think it was six of the 11 were, forgive my French, a shit show, right? They just didn't do what they were supposed to do. It was a complete mess. And all of them failed because there was serious misalignment. Healthcare algorithms are kind of paradigmatic case of normative AI. And it's a case where the parity model might, I think, be especially fruitful. Now, can the parity model really be built? Well, it remains to be seen. There are 2 people in this room now who are going to build it. I won't identify who they are. Okay, but I'm excited to work with them. All right, so I want to end with this kind of cold splash of water. I'm under no illusion that anything I've said here today will make even the smallest dent in our trajectory with technology. Like, there's a kind of juggernaut of large AI coming down the pike. Lots of money and lots of power is behind it. If the arguments that I've given you are correct, then what we're headed for is serious misalignment, serious problems. And I'm thinking maybe 75 years down the road, when those disasters have mounted up, someone might look back and say, oh, you know, there's this idea of making small AI, and maybe we should look at that. But by then, we'll all be dead. Thank you.
That was a really excellent talk, Ruth. Thank you very much. And I think we'll start with Alex.
I'd like to talk a little bit about the idea of hard choices and commitment. So I think that one of the virtues of AI is also one of its vices. And the virtue I have in mind is the idea that AI allows us to track and to pattern things that are novel. We might find, unbeknownst to us, some kind of pattern in the data that allows us to predict and explain things in a surprising way. And I think that that's a really interesting virtue of mining data using AI. But that, of course, brings with it a certain kind of vice, which is a kind of epistemic limitation, where we put ourselves in a position where often we don't know why it is that a certain output was given. Hold that thought. I think that Professor Chang's idea of commitment is really important, and I think it's one that puts us in a really interesting position to re-examine some of these issues like misalignment and what kind of future we want AI to bring for us, and also what to make of this virtue that is also a vice. So I think that this idea of commitment allows us to better diagnose, for example, why we might not want AI to take all of our decisions for us. I think it sounds to me like quite a repugnant future where we outsource all of our decisions and we outsource all of our work and we simply give everything to AI and have a pina colada laden lifestyle. And I think that the idea of commitment gives us one way of seeing what's wrong with that. We give away our ability to stand behind certain aspects of our life that we want to stand behind. But I think it also allows us to better see some of the risks of AI opacity, because AI opacity puts us in a position, in a bad position, to understand the basis on which certain choices are being made. I think when we're in that position, we're not well placed to rationally stand behind those decisions or to make a commitment. But the last thought that I have is that I think I'm a little bit less optimistic than Professor Chang is about how then to get humans in the loop. Now, I see that there's a kind of project, which is the parity project. Let's create this new way of doing things, and I'm excited to see how that goes. And I think it sounds really promising. But I want to just talk about the kinds of systems that we have right now and this idea of hard choices. Suppose that I face the hard choice between A and B. Maybe it's hiring someone, hiring one person or another. And we want to get humans in the loop. Let's just stipulate that this is a hard case. This is a case where A and B are on a par. And now suppose that I learn, or I don't learn, God from on high tells me, A has features X, Y, and Z, B has features F, G, and H. But suppose that these are features that are alien to me and that I don't understand. Suppose that they're features that lie in a black box and I simply have no access to. I think, again, that's one of the virtues of AI, that it gives us a way of utilizing alien properties and hidden patterns. But I think it puts us in a very bad position with being in the loop. And that's because if I don't understand the kinds of features that A has, I don't understand the kinds of features that B has, I'm not well positioned to be someone who can stand behind that choice between A and B. So I absolutely agree with Professor Chang that this idea of hard choices and making commitments is crucial, but I actually think that AI poses a unique risk with respect to our ability to be someone who can stand behind our choices. Thank you.
Well done. You win the medal for succinctness, Philip.
All right. Well, first of all, thanks a lot for a really exciting talk. As John said when he introduced me, I'm the director of the new Human-Centered AI Lab in the Institute for Ethics and AI. And I just want to note how exciting this is. Like, here we have a philosopher builder, right? So this is a project that says, look, we can think philosophically, systematically about choice and value, and we can actually turn that into a piece of code. And there are very few people in the world who are doing that. And I kind of want to add to that kind of two things. First of all, please use us. Right? Let us, if that becomes relevant. The other thing I want to say is that actually people are literally waiting for you to build this stuff. So, I'm talking to people who are working with companies like DeepMind or used to work at OpenAI, and they're like, yeah, like we hard choices sounds great. We want to see what Ruth is coming up with. So I just want to say, great, you're doing this work, and I think that there is actually a lot more scope for philosophers to have impact on technology than it might sometimes seem, as my feeling. So I'd be much more optimistic. Okay, but we're not supposed to just we're philosophers. We're supposed to kind of productively disagree with each other. I'm not sure I'm going to succeed because my views are actually quite similar with respect to the kind of centrality of values. So. Let's do something more specific. So some people say that last year in AI was the year of reasoning, and this year is the year of agents. Okay, and so now suppose we're looking at AI decision aid agents, right? That figure out how to help you with various decisions you might take. Okay, so now you might be in a situation where, say, you're about to graduate from college, and then, to use an old example of yours, you're deciding between philosophy and the law, right? Okay, and so that could be paradigmatically a hard choice. But if you have an AI decision aid that's getting you to that kind of choice problem, then presumably you've been using it for a long time already, and you will have also made decisions about what internships to take, what books to read, and so on. So it will have been in some way involved in that. And it kind of occurs to me that what is a hard choice for me is actually a very path-dependent kind of thing, right? Because as I make more lawyer friends, as I do some internships, read some books, go to classes, etc., I might put myself on a path where I do these things, none of them individually a hard choice as a result of having done them all a certain way. The question as to whether to become a lawyer no longer is a hard choice. And then from the perspective of the AI agent design, how do we deal with that, right? Like, so, you know, we could have it try to minimize the number of hard choices in your life by always putting you on a path to kind of gradually, you know, boil the frog of choice, as it were. Or we could say, no, you know, I want to play life on the hard mode. So I want to constantly feel like there are these hard choices. How do you think that agent design should sort of approach that?
So Alex, thank you, and Philip both. Thank you very much for those really, really great comments. So commitment is something that is supposed to be compatible with lots of AI. And why is that? Because if you build AI so that it faces the hard choices that are actually hard choices, then that's where the human is in the loop. Right, so the human really does have a role to play. Now, Alex raises the problem, well, look at machine learning right now. It finds out, look at AlphaFold, like cool, right? It can find patterns and criteria that never occurred to us. So when it comes to, you know, trying to hire someone for a job, we're too stupid to know that this kind of ability to sketch cartoon figures is actually related to some other skill that we need here. And so we need AI for that. And machine learning won't throw up the criteria. It's just some like secret pattern that we, right. Okay. So yes, I think we should use AI in those ways. But at the same time, small AI, right, puts us in the frame of a human choice. Like we want the best person for the job. We, stupid, limited humans, will throw up some criteria that are maybe incomplete, maybe inaccurate, and so on. But we can build an AI to give us a result that matches the covering criteria that we have come up with. And then we look and we see, oh, look, the machine told us this is the ranking of the candidates. And then we think, that's not right, right? Amy is way better than Bob. And so that can cause us to reflect some more about our criteria and the covering matters. I mean, I think what's true is that there is a cost in this way of doing things that Alex is rightly pointing out, which is machine learning might be able to do a better job, even in a large model, at identifying criteria that we couldn't identify ourselves. And then you have to weigh that against the misalignment it will produce. And I would prefer to have it identifies something secret that we couldn't figure out, gives us an output, and our intuition says, that's not right. Let's go back to the drawing board and think about criteria. But point well taken. Okay, so Philip is absolutely right. Path dependence, I'm totally on board with that. What counts as a hard choice for you in one possible trajectory of your future could be different from a different trajectory. That's fine. That's an argument for why we mustn't have large AI. We have to have small AI that's embedded in particular circumstances. So if someone's deciding between law and philosophy, and the circumstances are that they hang out with lawyers and they like lawyers and they've been paralegals and done a lot of Xeroxing and so on, then maybe going to law school isn't a hard choice for them. So an AI, if it's small, right, and if philosophers think that those circumstances are relevant for carving the problem of whether to be a lawyer or a philosopher at the joints, then that will be taken into account. So, yeah. I mean, that all sounds like you can say these things, like that you can create an AI for someone who's spent every summer as a paralegal. That's different from an AI that will help someone deciding between law and philosophy who has spent summers reading Plato. Right? And I don't think one has to go quite that far, right? The covering criteria can be things like engages you intellectually, feels comfortable or sits well with you. I mean, these are the kinds of words that philosophers use, but there are ways in which if you think hard about, two different career paths, you can think about how different covering criteria capture different experiences, different paths to the same choice.
Can I ask you a question? It looks like one of the merits of your view, the parity view, is that it kind of gives an answer to the question when a human needs to be in the loop, and we can't just leave it to an automated decision. So what would you say to someone who questioned that, who says that parity is neither sufficient nor necessary for a human to be in the loop? So it's not going to be sufficient. So let's say we accept that restaurants could be on a par. So whether you go to the Thai restaurant or whether you go to the Italian restaurant, particular one, or the French restaurant, they're on a par. So say I'm lazy about, and I don't want to spend my time choosing restaurants. I just want to have an automated system that when there is an event that's taking place and we need to go to a restaurant, it will identify what the options are and then automatically go for one from the bounded set that are on a par. It doesn't seem to me that I'm failing to make a commitment to Thai food or whatever by not making that decision myself. So it looks like it's perfectly acceptable in that case to set up the system to, as it were, randomly choose one of the restaurants. Okay. Alternatively, we could have a situation where there is a decision that is not a hard decision. It is totally clear cut. For example, the decision that you must go to prison for 20 years. But it seems like it's very important that that decision, someone stands behind that and is committed to it. So my question is, can you say a little bit more about the relationship between the parity point and when the human must be making the decision point?
Yeah. Okay, great. Thanks very much, Sean. So I completely agree, and I didn't mean to say that when you face a hard choice, you must make a commitment, right? You can commit or you can drift. And if the choice is trivial, so a kind of example I often use is, I get up in the morning, should I wear the blue socks or the black socks? Well, with respect to wearing socks and sartorial values, they're on a par. It's crazy to think I must commit to one or the other. So commitment is the kind of thing that is appropriate when the choice is something that can help make what I call your rational identity.
It wasn't pejorative.
The kind, not at all, right? You intentionally choose to do something. So, I mean, it's pejorative in the following sense. If it's really true that each of us has this really quite funky metaphysical capacity to endow things with value by just standing behind it, and if we never exercise that value, it's sort of a shame, right? Because we're not exercising this neat capacity we have.
I'm just worried about the opposite, over-exercising it, because there are going to be so many of these cases that to call them commitments seems a bit much.
Right.
But to call them drift sounded pejorative to me.
We don't want commitment across the board. So, many hairstyles are on a par for us. And to think that we must commit to a certain hairstyle is absurd. We often drift into a hairstyle. So the fact that a choice is hard does not require commitment. There are these two rational choices, paths you can take, commit or drift. And commitment is especially important and salient when the path is something, if you stand behind it, it helps create yourself as a rational agent, as someone for whom it's true that you have most reason to be a philosopher rather than a lawyer, right? That's what's interesting about it. But you don't have to commit between the restaurant.
And is commit only relevant when you have options on a par, or could you have so for example, I didn't think that because a lot of people don't believe in parity, right? They believe in equality of options. So say you have a situation where someone's a judge and they're considering two alternative ways of sentencing a young offender. One is to just send them to prison, and the other is to give them a community service order. And they've convinced themselves that these are of equal punitive or retributive value. Okay, now you may disagree with that, but let's just work with the assumption that they are. It does look like in this case it would be wrong for that person to flip a coin to determine what happens to the teenager. We want them to get behind one of those ideas. Yes?
Yeah. Okay. So I can get on board because
You don't
it's
agree with
very, very important that you demarcate the cases that are cases of equality from the cases that are cases of parity.
Right.
Because some of the resistance, I think actually quite a lot of resistance to parity involves thinking of cases as cases of equality that are really cases of parity. So what's the little test you can perform in your own mind? If you think, oh, look, this is a case of equality, take the two options, I can't remember what they are, and put them in community service or a prison sentence, right? Those are equally punitive or equally just or equally whatever the covering consideration is. Now perform the small improvement test. Add a day to the prison sentence, right? That, oh, I misread the minimum sentence requirement, and actually it's a day more. So that makes it more punitive than it was before. And if one day doesn't do it, make it 10. Does that settle the matter between these days in imprisonment and community service? No, it doesn't. It's not a case of equality. If you have two things that are equally good, when you make a small change to one that definitely makes it better, it has to now be better than the other. And the kinds of cases that are most important are not like that. They don't.
But Ruth, the equality cases don't have to be between trivial options, do they?
Not at all.
So if they're not trivial, some might think a coin flip is a trivial response to a non-trivial choice situation. No?
Yeah, so
So it looks like equality does not, therefore, coordinate with coin flip.
no, but that's because there are always extrinsic reasons. There can always be extrinsic reasons about, like, if it really is true that having the operation is equally good for your well-being as not having the operation, we would say for extrinsic reasons, don't flip a coin. You should think about it and, think about what you should do because it's such a momentous, important decision. But those are reasons that have nothing to do with how the options relate, right? So this is a distinction between intrinsic reasons for making a decision and extrinsic reasons, right? So it's like the flip side of which color socks should I put on? So trivial, just flip a coin and get it over with.
Okay, this is for the Thai restaurant.
Okay.
Take it further. Okay. Let's have some questions. I'm going to take 3 questions in a row, short, with a question mark at the end. Let's begin with David.
Yeah, thanks. I wanted to ask about the...
David doesn't need a microphone.
Yeah, I don't. I wanted to ask about this normative power or this metaphysical capacity to make one option more valuable than another. And I take it you think that AI systems couldn't themselves have a power like this, maybe in the near future, maybe even in principle. And I just wanted to ask a bit more about why. And the specific angle I'm interested in is whether a lesson from this is that we would want artificial systems, if we were to hand over even hard choices to AI systems, we want systems not only that could understand or grasp moral values, which is already a long way off, but also systems that are somehow, or agents that are kind of sources of value themselves, or that can have an identity or something like that.
Anita?
I'll be as brief as I can. I was really struck with the structure of your argument, because it reminded me of approaches in philosophy of mind to, say, reductionist approaches to consciousness. Let's take that, for example. And I thought, well, but people who are taking the reductive approach are going to say, look, we've tried the top down, it doesn't work, we've got to go bottom up, okay? So then I'm thinking, okay, I thought you were going to have a kind of in-principle argument against AI being able to accommodate normativity, but that's not where you went. You actually think there is a way that AI can accommodate normativity. And I guess I wondered whether somebody could come along and say, actually, you're just, you're still taking a bottoms-up approach, because actually normativity can't be, right? You can't get there from here. So I guess I wasn't so convinced by how you were going to do it. It seemed to me somebody could still come along with a kind of harder
In
case.
philosophy, there's always someone who comes along, but there's one more question there.
Thank you. I've always thought that parity cases, you can solve them, you can choose also just, picking the right covering consideration, right? So maybe the two things are on a par, but if you switch the covering consideration, just put another value, and suddenly one of the two options is clearly the better one, and you choose that one. If that's so, is it the thought that we can sort of input, a value into the AI and say, well, this is for this year, 2025, this is going to be this company's, commitment, is going to commit to this value. So you want the AI to identify a hard case, and then, to use this value that was input to choose. And the question is, I think some people might want. So I think some people want efficiency, and say some people want the AI to be able to make this normative decision, but they also want efficiency, right? So they don't want to have to open the machine too many times to see the human inside. And so, but you say the humans in the loop have to keep making these adjustments. No, maybe now there's this different value. Maybe this other value. And so, are you open to a company saying to you, yeah, I just want to put this one value and just close the machine, no humans, because I also want efficiency. Right, so I want a normatively efficient AI and not having to open it that many times for a human to come in and just change the value it's gonna be important. Will you be open to that?
Great.
That's
3 questions.
fantastic. Can I start back? Can I go backwards? So I think Javier's question gets to the real deep point about the parity model, which is that it has a vision of value that evolves over time. So it's not that the values are out there and then we just have to kind of discover what they are, and then, right, and then the machines aren't good enough, or the machines will recognize that there are hard choices and then it has to come back. No, the point of hard choices or hard cases is that they really are cases where the reasons or the values, if you like, run out. And so now it's up to us as humans to put our thumb on the scale, if you like, in favor of certain values as opposed to the others. And then that actually changes the algorithm going forward. So it actually gives more weight to, say, team spiritedness when you're hiring and the company comes and says, look, here's the thing that we care about, team spiritedness. We want a closed system, meaning trichotomous system, where the machine will tell us, candidate A is better, worse, or equal. If it's equal, flip a coin, and we're done. Humans don't have to be in the loop. If values were like that, then we could create machines that could reflect trichotomous values. But the idea behind the parity models, values are not trichotomous in structure, they're tetrachotomous in structure. And the way we can make decisions then is by adding value through our commitments to certain considerations as opposed to others. If you want an efficient machine that distorts human values, sure, go trichotomous.
I thought the point was that you could automate your commitment.
Oh yeah, okay. So good, thank you. Can we take the parity model and just make a fully autonomous AI on the parity model? Well, here's an idea. When the machine hits a hard choice, the machine, which is really smart and knows a lot about the hiring committee, can predict with 100% accuracy what the hiring committee would commit to, and thereby forget about flagging, this is a hard choice, I needed the human in the loop. Cut the human out and let the machine predict what the humans would commit to, adjust the algorithm all by itself, and go processing without humans. The problem with that is the thing I started with, which is if values evolve right? Then there's going to be misalignment because the machine has predicted what you, Javier, would commit to, which is team spiritedness. But guess what? You haven't done it. You haven't actually committed to team spiritedness. You haven't considered the hard choice and stood behind team spiritedness, thereby endowing it with value. Instead, what's happened is the machine has predicted that this is what you would commit to and now gives extra weight to team spiritedness. But then next year, when it does its thing and it gives it to Betsy, the cheerleader, right? We're like, what? That's not what, that doesn't align with our values. And that's because we never committed to team spiritedness. Right? So that's another way to get misalignment. And that's why the human really has to be in the loop on the parity model. You can't do without the human. Okay, then Anita. Right. Okay. So yeah, I totally hear you about the this kind of trajectory of argument. So I thought the thing that you said that was, to me, something that I find very compelling is the idea that, look, you can't capture normativity computationally. So values are just not computationally tractable. So Bryce Goodman, who's a graduate student here, has actually written an article saying, hard choices, they show the hard limits of AI and technology. Right? If you've got these hard cases of parity, that shows you computers can't capture our values. And I think I'm more optimistic. And that's because you can use math to represent anything. You really can, if you just get the right interpretation. And you're absolutely right, though. That's the tricky bit. And thank goodness I have Kit Fine on the team who's working this out. Okay. Then David, great question about, wow, if we have, this is the year of AI agents. So what do people mean by AI agents? I mean, the kind of thing they have in mind is not what I think you and I would think of as genuine agency. So before an AI could commit to something, before an AI could itself be a source of value, I think it would have to tick a bunch of boxes that we're not too sure about right now, like consciousness, perhaps. It has to have moral status, a bunch of other things. Pardon?
Living a life of something.
Living a life, yeah. So, not sure, yeah.
We're ready for another 3 sets of questions. So Rebecca, Yuval, and Emma. So let's begin with Rebecca here.
Thank you, Ethan. Thank you so much for a really, really fascinating insight. And I'm sorry, this may be a question from a lawyer because I'm not a philosopher. But I wanted to ask you about the lines between evaluative and non-evaluative and normative and non-normative, because you were just saying that anything can be captured mathematically, and that's right, it can. And yet you were saying sort of near the end of your talk that your hospital example was a classic example of a normative decision that it was not surprising that an algorithm had failed to be able to cope with. I was wondering where your lines are relative to things that we just can't measure, like happiness. I don't know what metric you would use to measure happiness. And when it's a question of, well, actually we can measure it, but we might differ on what it is we're looking for. So, for example, candidates for a hire, yes, I might pick team spiritedness and you might pick, I don't know, innovation, but we could probably find ways of measuring each of those. I could find, I could sort of give a definition to that, which was number of times you interacted with other members of the team cooperatively. You could have a definition of, different instances of new things you'd created in the sort of workplace. So that seems to me less of a measuring problem and more of a, well, we just value different things. We want to measure different things. We think different things are important. Our target variable is different. So I just wondered how those things of non-measurability and, measurability, but we differ over them, how do they fit onto your evaluative, non-evaluative, normative, non-normative pattern?
Great. Yuval.
So another lawyer, I'm afraid. And the question is whether law makes any difference in categorizing certain choices as hard choices or easy choices. I mean, some of them issues, the autonomous weapons issue, which I've worked on. there are values, and then these values, they are often being deliberated and represented in rules that have been adopted by legislatures or what have you. And they sometimes make stark choices, so civilians or combatants or what have you. And you may be, as a philosopher, somewhat concerned about the way in which these laws have been articulated, and maybe you can be critical. But the question is whether we see, when we instruct the AI to follow the rules, are we in a way obfuscating a hard choice? I mean, is this something that we should be concerned about, that we are in a way created a false negative regarding a hard choice? So how does law could disrupt potentially your model, to the extent that we have a sophisticated legal framework that makes already some of these choices that you now expect the AI to actually try to handle?
I don't know if I can reach. Thank you. Thank you for the talk. It was such a treat. So my question is, I suppose, to clarify the nature of the relationship between these two problems. So with respect to the covering problem, at least to me, I can think of certain axiologies in which I can imagine non-evaluative proxies being pretty good, right? So I can think of, welfarist aggregative axiologies and think, oh yeah, we can come up with some pretty good proxies that are non-evaluative there. But what becomes, makes it harder is if we start attending to more values. At that point, I start thinking, how are we going to get these proxies that are going to, be accurate for each of these things, but not accidentally let other things in? So I wonder if there's something to that, whether or not the considerations about value plurality make this coverage problem a bit harder.
Right. Okay. Just because I have a weak memory, I'm going to go backwards again. So yes, so there are two ways in which values can be straightforwardly, trichotomously, computationally tractable. One is if the value is what I call cardinal value. So one value is the value of the number of lives saved by this policy as opposed to that policy. That's computationally tractable. 2 lives is 1 unit better than 1 life and twice as good as saving the 1 life, right? So that's no problem. We can be trichotomous about some values. Another way, some people think this, and I just put it out there, but I disagree, is that if you have a single covering consideration that is probably thick, right? Because the thick ones seem to be, well, there aren't components, there's no multiple criteria that you have to weigh against one another, there's just courageousness, right? Or tawdriness. And if all of our choices were like that, where only one thick covering consideration was relevant, then that's another way in which perhaps trichotomy could get a foothold. I actually think that's not true. There's sort of, I don't know, example, just qualitatively different sorts of instantiations of courageousness. Really? One's got to be better, worse, equal? Aren't they just on a par? Anyway, okay. But I don't think most of our choices are like that, right? The fact about plurality in life is something that is with us, and I think it's just true. So that's where the possibility of hard choices rears its ugly head. Is that responsive? I'm not sure if I got the heart of what you were after.
I was wondering about the relationship. I see how the hard choices raise up, but I wonder if, because of, thank you, it was more about the relationship between that and the concerns about proxies not being good proxies.
Right.
So
okay.
whether or not
Yeah.
the fact that we have multiple values to attend to is going to make getting a proxy that doesn't let other things in, or, is not going to capture everything, much harder. So if there's some relationship between the two problems you outline.
Yeah, so I think you're absolutely right. Human life involves choices between things that what matters are usually multiple values, and then there's this trade-off problem and how to get non-evaluative proxies to cover exactly and only that list of plural values and their normative relations, right? Described that way why would we even imagine that non-normative proxies could do that work? So I agree. Well, I think that we humans are pretty good at making evaluative judgments. And we have this amazing computational power right now at our fingertips. And to me, it's just absolutely mind-boggling that we haven't, apart from a few outlier examples, turned this power on values, that is, evaluative judgments. Like, it's there in the foundation models. Are you kidding? The internet is full of evaluative judgments. And let's turn machine learning on evaluative data, not non-evaluative data. Okay, so you've all totally clear that I think you're right, that the law can turn a choice that would otherwise not be hard into a hard choice, but only if that choice was well-formed in a way where the law's dictates was one of the covering criteria, was relevant to the case. And similarly, the reverse. So law could create a hard choice where it wouldn't be a hard choice and so on. Okay, so I take that on board. I think that's exactly right. Okay, Rebecca gets right to the heart of the matter, right? So the way you think about AI and values is exactly, you put your finger right on it. Are you kidding? This is like Anita's problem too. How do you measure a value? Right? So if you want to make values computationally tractable, you have to give a numerical representation of them, right? Of the value. And some values may be sort of more amenable to that rather than others and so on. And the beauty of the parity model is that it steps away from this tendency we have to use math to represent the value of things. Instead, on the philosophical model I've developed, and I've now tried to get mathematicians to, right, the unit of measurement is not the value of something, but the evaluative difference between two things, right? So you might say, well, how is that an advance? Well, the thought is that we can have, like, so this is what people actually do, right? People who create the indices for well-being in countries, they say things like, here's a scale from 1 to 10. Tell us how important it is to you to have education or healthcare, and you tick a number, right? So that's an attempt to get a numerical representation of the value of these things. My thought is that that's, apart from, interpersonal comparability and all sorts of problems with that approach, it seems to me more informative and still within our ken, just within our ken. It's not as easy as a scale from 1 to 10. Is the difference in having a high school education at least twice as important as having medicine when you're home with a cold or something like that? And you can get, I think, elicit from people claims about the range, right? So I might say that having higher education is at most 50 times more important than having access to medicine. Like, let's suppose you're not going to die, but just comfort. At most 50 times more important. And at least 10 times, and if you take that kind of data, you can make, right, you're never representing the value of things. What you're doing is you're representing a value of differences.
I think we've got like 5 minutes to go. So I want to give the commentators an opportunity to have a second bite of the cherry, as it were, in light of everything that's been said. So Alex, do you have anything you want to say?
I think I'd like to just try to better understand how the evaluative model that you're proposing sort of builds from the ground up, as opposed to is something. I mean, I think what I'm wondering is, do we in effect have to sort of start all over and stop using the kind of models that have made huge progress? Is small AI, so here's sort of what came to mind when you said small AI. My sister-in-law works for a big accounting firm, and they basically brought in OpenAI and said, we want you to build us a thing for us. But it's basically ChatGPT, just with all their data and none of the other stuff. Is that small? Does that count as small? And then another direction that small could go is sort of just back to good old-fashioned AI. And I think we probably aren't, like, certainly it's bolted, like the horse is out. We're not going back to good old-fashioned AI. So I think I would just want to have a better understanding of kind of like, how much is this sort of start from the ground up versus massage the thing that we've got that people are really excited about, that quite frankly isn't, we're just not going to draw back.
Okay, I think that's a really good question. So here's something, I don't know how many like computer people are here, but the first thing that will strike a computer person is, what? We can just do this with reinforcement learning from human feedback, right? Let's just take our foundation models, which are trichotomously built on Boltzmann rationality, that have the back propagation that's trichotomous, and then, you know, look at the outputs, and then we get a panel of humans and say, that output's better than that one, and we add parity. And we say, we allow the human panel to say, you know, that's a hard choice. That outcome's on a par. And then the hope is that the machine actually learns this new concept of parity. Okay, so two things to say about that. One is, hasn't been done obviously yet. Second is, if you look at the literature on reinforcement learning from human feedback, it's, I haven't found an article yet that gives you a general account of the limitations of reinforcement learning in correcting any errors in the foundation model. But there are lots of articles about how reinforcement learning cannot correct specific errors in the foundation model. So strictly, it's an open question as to whether or not it can learn. I don't know. So I think that's probably maybe one of the first things we try when we try to build it, because you don't want to start from the ground up. But having said that, it isn't that hard, I think, to tweak. Well, I shouldn't say that. I don't really know. I would like to get my hands on, I mean, obviously I can't, but if I could get my hands on a foundation model and just try tweaking by making it okay to assign multiple weights to nodes. Right, so you probably do that, I don't know, maybe with a reward function or something? Phil may know more technical.
My first thought was like, why we need that, right? Because presumably if we're interested in value judgment, I mean, actually, I've kind of got a broader question about, I mean, if we're talking small AI, if we're talking about decision making, there's sort of the question, okay, what are the kinds of like data trajectories that would even make sense to learn from, right? Because if we're dealing with hard choices where, you know, commitment is involved in effectively partly determining what's going to happen, you know, further downstream in terms of what you're now committed to. Okay, fine, now your values kind of adjust in some sense as a result of your commitment. I mean, that's fairly hard to do in a purely hypothetical way, right? So I'm wondering to what extent you'd have to effectively train up that kind of small AI as effectively your personal system that in some sense has to grow with you, because it needs to effectively learn from you actually making choices, as opposed to just, say, considering a bunch of hypotheticals. Because, like, say, oh, like, you know, if somebody asked you, would you like to be a philosopher or a lawyer? Like, well, okay, no, this is like a totally sort of hypothetical thing. I'm not sure that. I mean, I can't think of a particular reference right now, but there obviously is a well-known gap between what people are going to say they're going to do if you ask them in the abstract and what they're actually going to do if they're in a particular situation. So that's one thing I was sort of wondering how you sort of see that, whether building a system like this would really involve having to kind of build a companion for you that really has to kind of be on board for quite some time.
Yeah. So if we have a world where we each have an individual AI companion, yes. It's got to live with you, watch you make the commitments, adjust its values, and so on. But I'm thinking AI can be used for, like I said, carving at the normative joints for hiring in hospitals, right? Hiring for a particular nurse position in a hospital. That could be a small AI. I mean, exactly how we carve at the normative joints is difficult. That's something that we philosophers have to figure out. But it doesn't have to be individual. It can be, whole governments or institutions making certain decisions if they carve at the joints. So where the objection is, I think, is that, well...
I'm not sure it's an objection. It's more of a kind of... I'm kind of interested in like how we can turn all of this into kind of concrete design criteria, right? And then that's the another thing I was wondering about. I mean, just in terms of kind of technicalities of it. I mean, I also say on my website, okay, first you got to have the concept, then you mathematize it, then you turn it into code. But if you're working with things that you can kind of specify at the level of natural language, which I guess is often the case for the sorts of values that might figure in hard choices. I mean, there's also the route of just effectively having it as a kind of reasoning chain just at the level of natural language. You're like, okay, what problem? What are you deciding today? Oh, I'm trying to decide what career I'm going to have. Oh, okay, and now, step one, find me a list of careers with the following basic criteria. I mean, you could just write that as a kind of chain of thought prompt without having to like get into the weeds of what individual weights are doing, because at the end of the day, you probably want the system to generate like output in natural language potentially, or so.
So existing...
now.
Okay.
So it's a lot weighs on this.
Yeah. So existing AI does exactly what you just described. So if you go to Chat GPT, and I can't wait for 5, it'll say things like, well, do you like talking to people a lot? Well, then how about these careers? How about, right? And at the end, if you really, really press it, it'll just say, it depends on what you want. It never says, this is a hard choice. And it can't, because it doesn't know enough about you, right? It's just a kind of abstract, if you care about these things, what I have in mind is something much more sophisticated. But whether...
You could just be super explicit about what you want it to do. Right?
Well, whether this works depends on data. And I just don't know whether the data is there. So this could all just not work at all. Yeah.
And that is the usual conclusion of any philosophy seminar. So can we thank our speakers for a really wonderful seminar?